Hello, my name is Vasilios Kosmakos. Today's March 7th, 2022. I have the pleasure of speaking.
I'm Dr. Karen Neely, a research scientist with Nova Southeastern University.
Fantastic. So, Miss Karen, if you can just tell us a little bit about who you are, kind of how you grew up, and how you got to where you are today.
Yeah, absolutely. So I grew up in Colorado, quite far from the ocean, but just like most kids, think I wanted to be a marine biologist when I grew up, and I say that I just never grew out of it. But I moved to the Florida Keys for the first time to work here at Seacamp, a pretty magical environmental education foundation. It was the first time I'd really even heard of the Florida Keys, but I came down and really fell in love with the place. And so when I went back to grad school, the Florida Keys was a big part of my work on coral reefs and coral ecology. So I ended up doing some of my PhD back down here, and then once I finished up, moved back down here and have been working on Florida's coral reefs pretty much full-time since then.
So tell us a little bit about kind of your early research interest and your current research interest. How did that kind of passion and interest evolve over time, and how did you end up where you are now?
Well, again, I think when every potential marine biologist is 7, they want to study dolphins. But after my undergrad, I took a position out in Australia, an internship doing coral reef ecology, and that was sort of my introduction to this pretty magical, diverse world of reefs. And then my PhD was actually all on reef ecology. I'm fascinated by how, corals and inverts and fish and how they all interact together, and what home means to those different types of animals. But it's almost impossible to be just a researcher with coral reefs anymore. Everything has to have a conservation message because these reefs are in so much trouble. And we have major problems with Florida's coral reefs right now, and that's the road that we're all taking. It's really just doing everything we can to try to help solve these problems, identify these problems, and ultimately conserve these reefs by addressing these problems.
So you mentioned a couple of issues, right, that the coral reefs are facing.
Yeah.
Just generally speaking, what are some of those?
This is certainly, coral reef issues are global, and they've been going on for a very long time, but they're certainly increasing in number and in magnitude. Here in Florida, we're constantly addressing the impacts of climate change, whether that's sea level rise, which here in Florida, you can see we're about 2 feet above the ocean. Places like this get hit hard when we start talking about sea level rise. And so the coral bleaching, which comes along with warmer water temperatures associated with that, hurricanes that may be increasing in frequency and or severity associated with that. Ocean acidification is something that's going to become an increasing problem down the line. But then we also have a lot of issues related to water quality. We know that corals are more stressed when their temperature or their water quality is subpar, and we have major water quality issues here, both local and global. And that certainly impacts things like disease. When these corals are stressed, or when it's hot, or when the water quality is bad, we know that there is more disease is more virulent, and so we're dealing with that as well. We talk about coral reefs being the death of coral reefs being by 1,000 cuts. So it's so hard to pick a single thing, but everything from a person dropping an anchor on a single coral or kicking one with their fin to global climate change. These are all things that we're having to address simultaneously and in parallel.
So first, I would like you to talk about more of the kind of global issues affecting corals, right? So climate change, coral bleaching. Talk about synthesize those issues, and then after that, I'd like you to talk about more of the localized issues that the Florida Keys are facing, and then and kind of the difference in the similarities between those two events.
Sure. I think it's hard to differentiate these global and local issues sometimes, but I think broadly, probably the most global issue impacting corals is climate change. It's something that's so hard to address locally, but something that obviously everyone needs to address locally. And so when corals get too hot, when corals get stressed at all, they can undergo what's called coral bleaching. So corals have these symbiotic algae that live inside of them, and when that symbiosis breaks down, the algae are no longer in the coral, it appears white, and it's called coral bleaching. Coral is still alive, but it's essentially slowly starving. Those algae are no longer able to provide it with any sort of sustenance, and so if that bleaching carries on for too long, that coral will eventually starve to death and then die. Even if they don't die from that, we know that that can have impacts on their reproductive capability for up to years afterwards. So they might still be alive, but we're losing future generations of corals through that process. And so, for a long time, bleaching was really quite rare. It was mostly associated with things like a large freshwater runoff event. But since really the 80s, we've been seeing bleaching more and more and more, to the point where, almost every year there's some degree of bleaching or at least paling here in Florida. And that's all thermally driven. That is, the summers are hotter and hotter for longer than they have been in the past. And so even though so we had a lot of coral bleaching events in the past couple of decades that have killed off large numbers of our corals. The ones that are survivors are obviously pretty hardy. They were able to make it through that. But, they are impacted. They lose some of their reproductive capacity. They are stressed more and more every time that they bleach.
So,
that was a lot.
Sorry. So you mentioned the loss of the algae that lives in living coral, right?
Yeah.
I think it's called zooxanthellae, right?
Zooxanthellae, yep.
So, and then, would you mind describing, and you also mentioned how it kind of has an ability to kind of come back though after a while, right? Describe that a little bit more, and describe maybe some ways that we can kind of promote that, within systems.
Gosh, that's a really active area of research, and I wouldn't say we have an answer for that yet. The easiest way to get zooxanthellae back into corals is to take away the stress. So once it cools off, that symbiosis reestablishes itself, and those corals begin their healing process and generally go on to be fine. So if there's ways to reduce that stress, whether that's sort of long-term by addressing climate change, or there's some examples, very local examples, where the Great Barrier Reef, they have put up little shade areas over some of their high tourist reefs, and that has provided that opportunity for those corals to regain those zooxanthellae. That obviously is really only feasible on a very, very small scale, but that's addressing it by taking away the temperature stress. There is some interesting work going on to look at sort of stress hardening corals. Are there ways to help adapt them, for example, in a laboratory setting where this is their new norm, they are now used to warm temperatures. And so if those could be outplanted into the field, maybe they'll have a better outlook when these bleaching events come along. And that is happening, but it is very experimental and small scale right now, but it's a really active area of research for the future.
Corals are a pretty diverse kind of group of animals, right?
Yeah.
Is there any kind of genuses or families specifically within coral that are more resilient to climate change as opposed to others? What families or genuses are kind of taking the brunt of climate change?
There are, and that our knowledge on that has changed over time too. Back in sort of the 80s and 90s, those first bleaching events, people were saying, oh, these are really not very susceptible. But that was in 1990 temperatures. We now know that pretty much all of these taxonomic groups are susceptible. I can't think of a single coral species that I've never seen bleached. But some do survive better, for sure. There's ones we think of as kind of more weedy corals, they're, we have them kind of just out here in kind of subpar conditions. They're just hardy, they do well. Pseudoastrias are some examples of those, and they'll often bleach but seem to have much better recovery than some of these other species that are actually much better reef builders. That's one of the problems. These weedy species aren't really very good at providing a lot of the ecosystem services that we really need from some of these ones that can experience very high mortality from bleaching.
So global scale, almost all corals, right, or all corals are affected by global warming, right, and increasing temperatures. On a localized scale, though, however, in Florida Keys, water quality is becoming an increasing issue. Water quality has kind of degraded since the 1970s, right, as development has happened in this area. Speak specifically as to how water quality is affecting, a decrease in coral abundance, and specifically the way the disease is affecting that.
Yeah. I mean, so just to kind of address water quality, this has been going on for decades, as you sort of mentioned, and there are very local causes and there are much more broad sort of Florida scale causes. And, you know, we're downstream of everybody. Anything that happens in Okeechobee is ultimately going to impact us here in the Florida Keys. So we're not just talking about local water quality, but really much more regional. And there have been a lot of efforts locally to reduce water quality problems. Some of those have been really quite effective, but we're working in this patchwork of water quality issues. But, you know, we do know that water quality impacts reefs and poor water quality negatively impacts reefs. Sort of worldwide, water quality is often tied to algal growth on reefs, particularly increases in nutrients, nitrogen, and phosphates that come from fertilizers and sewage and all of those sort of human-based things promote algal growth. And algae and coral are competitors for space on the reef. And so when you increase the ability for algae to grow, you're increasing their opportunities to outcompete coral. That seems to be mediated a little bit here in Florida, probably because we have a lot of good algal grazers. A lot of our herbivorous fish populations have not been over-harvested like they have in a lot of other places. But certainly water quality can change those algal coral dynamics. They can be detrimental to corals in the right amounts or the right types of pollution that you're seeing. And then sort of as a result of that, we know that they can increase the stress on these corals. And a stressed coral is more likely to be more susceptible to maybe thermal temperatures. It can be more susceptible to disease. It can just not grow as fast and be able to heal or reproduce. So all of those water quality parameters, even if they aren't directly affecting a coral, can really impact the reef through a lot of those ecological connections.
So besides, you know, this idea that, you know, increased nutrients, increased temperature, increases stress, right, which makes the coral more likely to be sick, is there anything, is there anything specifically within the water quality, right? So is there any bacteria coming from the effluent, right, that's causing corals to be sick?
I don't know that I could comfortably say conclusively that that's true. Certainly theoretically that makes a lot of sense. The disease that we're dealing with right now, Stony coral tissue loss disease, is devastating, you know, really pretty unprecedented in Florida and the Caribbean.
I'm sorry, can you repeat the name of the disease one time?
Sorry, yeah, Stony coral tissue loss disease. It's a mouthful. We call it SCTLD for short. There are some experiments going on right now to look at whether nutrient enhancement would impact SCTLD transmission and or virulence. So putting SCTLD corals into tanks, some of which have poorer water quality, you know, experimentally manipulated poorer water quality versus better, and looking to see whether that impacts how quickly they die or how readily that disease can transmit to healthy corals. So far, I haven't heard much from those results, and what I have heard doesn't seem to immediately indicate that water quality impacts that, but you know, that's pretty preliminary and you know, certainly also very immediate and not thinking about what does this look like over 10-year or 100-year scales as well.
So is the research being done on that fairly recent? As in,
I think it's ongoing like today, yeah.
As in, like, I guess my question is, like, is this research that started in the last 5 years, or has it been going on for a couple of decades, or?
So certainly with SCTLD, this is a very new disease, and so any work that's going on with that is, you know, at most 5 to 6 years old. I would not be surprised if there were other diseases that had been looked at with water quality, but I couldn't specifically tell you any information about those.
So kind of circling back to this idea that, you know, algae competes with coral, right? Kind of explain that a little bit more. What exactly does that mean?
So for most coral reefs, space is the limiting factor. Space is at a premium. And so if you don't have a space to land as a baby coral, you don't survive. You don't land there and form an adult coral. And so this sort of competitive nature can be impacted by lots of things. And in an example where coral and algae are both competing for space, if you are, for example, providing nutrients that allow algae to grow faster, then you're shifting that balance more toward an algal growth over a coral growth. If you remove herbivorous fish, for example, that like to graze on that algae, then once again you're starting to shift that one way or another. So there's a lot of ecological factors that can impact that one way or another. And obviously to have what we call a coral reef, you need coral.
Interesting. So, what exactly? So, we talk about nutrients a lot, right? And you mentioned how a lot of these are coming from Lake Okeechobee. Is this largely a result of agriculture, or what? Or is this something more domestic? Where are these nutrients coming from?
Ooh, that is a question for someone more of an expert than me on that. I think part of the issue with Florida and water quality is there are so many contributing factors that it's very easy for everyone to point the finger at somebody else. And that makes it hard to get stuff done because, everyone is saying it's not us, you need to go regulate them or go fix that problem first. But certainly some of the contributing factors up in Okeechobee are really likely to be agriculture, really likely to be the growth of Orlando, just in terms of sewage and things like that. There's a lot of different industries that are happening in that area, whether that be agrarian or sort of tourist and commercial. And all of that has obviously been having a lot of impacts, not just there, but throughout the state because that water moves through most of Florida.
So I know that you specifically study stony coral tissue loss disease, but what are some other major diseases that are affecting our coral populations?
Yeah, disease is a natural part of any ecosystem. We don't want to say that there should never be any disease. We know that is a part of ecosystems. We have learned a lot about coral disease. Really, the first time it was documented in corals was probably the late 60s, early 70s, and since then we've named a lot of new diseases and found a lot of new diseases. Part of the reason those numbers are growing is probably because we've been looking, but it's also become really quite clear that there are diseases that we see a lot now that we did not see 30 or 40 years ago. Like the prevalence and the virulence is definitely on the rise as well. But some of the sort of standard ones, at least in the Caribbean, white band disease hit a lot of the branching corals, or what we call the acroporids. That happened back in, I want to say late 80s, early 90s, and essentially wiped out those two species in a lot of areas.
What species?
Acroporids, so Acropora palmata and Acropora cervicornis. What are the common names? Elkhorn and staghorn. And those used to be major reef builders, and particularly the Elkhorn really dominated the reef crest and was essential for the habitat and stopping those big storm waves that came in. And it's really pretty rare now. There are a handful of reefs that still have some of those Elkhorn thickets, but for the most part, white band disease really wiped them out throughout the Caribbean. I think estimates of 90 to 95% of colonies disappeared as a result of that disease. So that's kind of a somewhat famous, if notorious, example of a disease that dramatically impacted Caribbean reefs. White plague is a disease that impacts a lot of boulder corals. That's been documented over the last couple of decades. Black band disease is an interesting composite of a group of pathogens that work together and can wipe out some of these corals. You can tell how creative we are with the names. Black band, white band, rapid tissue loss disease. So I would say those are probably the biggies that have gotten the most media over the years just because of their impacts. With the exception of white band, which I said really knocked out a lot of those, the population of those two species through the Caribbean, most of these other diseases sort of act more like diseases in natural populations. You'll get little flare-ups, which can be devastating very locally for a short period of time, but then it just kind of dies back. It's like flu shows up in Mrs. Smith's second grade class. You know, it doesn't really impact the next town over. It's just kind of a local little flare-up. One of the things that's so dramatic about stony coral tissue loss disease is what we call the temporal and the spatial scope, is that this has not just been a local flare-up. This wiped through Florida, is still wiping through Florida, and has since moved to other parts of the Caribbean. And it wasn't just a short-lived couple of months. We're now, 7 years into a pandemic, really is the right word for stony coral tissue loss disease.
So just like in freshwater, right, I would imagine that increased global temperatures are a breeding ground for bacteria, right? Would you say that's accurate for saltwater as well? And kind of elaborate on the connection between climate change and this, kind of what's the word, virulence of disease that we're kind of seeing in corals.
Sure. I know almost nothing about freshwater, so I can't compare it to that at all. But yeah, I'm trying to remember the authors of this paper, and I can't, but I can send it to you at some point. But there's a really interesting recent paper talking about disease in corals and what we should be looking at for the future based on models of climate change. And sort of based on increased temperatures are better breeding grounds for pathogens, will also increase the stress on the victims of these pathogens, in this case the corals. And so what's that going to look like? Are we looking at this being 50 years down the road, 500 years down the road? And really the conclusion from that paper, at least in the Caribbean, is that bleaching and climate change stresses on corals directly tied to just being too hot are probably not going to end up being quite as important as stressors on corals from disease because it's getting too hot. That's probably the way we're going to lose even more of these corals is because of disease, because of this climate change thing. I'm not sure we really see that with stony coral tissue loss disease, so I have to put that little asterisk there. Most coral diseases we see peaking in their prevalence in sort of late fall, after many months of warm temperatures. Generally when corals are the most stressed, we get real upticks in things like white plague or white pox, some of these other diseases, black band disease, almost always have sort of a seasonal peak to them. We don't see that with stony coral tissue loss disease, and that's kind of interesting in and of itself, but kind of an important caveat that not all diseases behave the same.
So how many years have you specifically worked on corals within the Florida Keys?
Gosh, too many. No, not too many. Not nearly enough. So I came here to Seacamp in 2001. And so I wasn't researching at all, but that was sort of my introduction to these. So I've been diving Keys Reef since then. And then, let's see, I started grad school in 2002. No, that can't be right. I don't know, somewhere around there. And that was when we really started doing research on Keys Reefs.
So, in your kind of anecdotal experience, right?
Yeah.
What have you seen in terms of loss and degradation in your kind of lifetime?
Oh, it's incredibly noticeable. And I don't even feel like some of the old timers who've been diving here since the 60s or 70s, a lot of them will say they don't even dive anymore. It's just too sad.
Wow.
They can't go out and see these places that they used to think were so beautiful. And a lot of that really is tied to the loss of those Elkhorn corals up at the top. That was a very dramatic habitat, great for snorkeling, and it really just doesn't exist anymore. So you can kind of tell how long someone's been here by the way they describe the reefs when they first got here. For me, by the time I started, those Elkhorn thickets were long gone, but even just in the 5 years we've been working with stony coral tissue loss disease, the loss of corals is significant and substantial and very, very noticeable.
Within 7 years?
That's really hard.
Wow.
Yeah, this is a catastrophic disease event that has had really dramatic impacts. So I started 2013, I think, we started a project on a coral called pillar coral, which is not super common, never has been super common, but is very iconic. It's a large coral. It forms these big columns It's fuzzy, so it's kind of cute as far as corals go. And the coral was up for listing under the Endangered Species Act, and we wanted to assess what the population was in Florida. And so we went out and found all these colonies. I think we documented 800 or something throughout the state of Florida. And we are down to like 10.
Wow.
Yeah, there were some losses before stony coral tissue loss disease. We had a bleaching event that took out a handful. We had some white plague that took out a few here and there, but really stony coral tissue loss disease just came and wiped this species out entirely.
And you said this was over the course of roughly 7 years, from 2015 to
Yeah, well,
now?
so stony coral tissue loss disease started in 2015, and really as it worked its way through the Keys, we lost them. We could even use pillar corals to track where the disease front was, because they would be one of the first corals to get it, and then they would be dead within, weeks to maybe a couple of months.
So, so would you say that some corals are, indicator species in terms of disease or anything? And can I explain that a little bit?
Yes, although it does depend on the disease.
Yeah.
Stony coral tissue loss disease, we have roughly categorized species into what we call highly susceptible and moderately susceptible, which I don't love the use of the word susceptible. To me, that suggests you're much more likely to not get it. But what that really means is it's going to take you longer to get it, and it's going to take you longer to die, which is kind of a grim way to put it. So again, I think when people hear moderately susceptible, they're like, oh, maybe it'll be fine. It's not going to be fine. It's just going to take longer to see those impacts. But yeah, for stony coral tissue loss disease, pillar coral, and a handful of others, especially a lot of the brain corals, they get it quickly and they die quickly. Some of our other more reef-building corals, it takes them longer to get it, and some of them can survive it for several years, but they're still going to ultimately die.
So, you've kind of mentioned this term reef-building corals quite a bit.
Yeah.
Explain what that means.
Sure. So we have something like 45 different species of corals here in Florida. I would say about 20 of those you would almost never see or would never really notice. We have little like single polyp cup corals or things like that. And they're super cool. The diversity is important. Having any species plays some role, right? and if you lose those species, you don't necessarily know how that's going to negatively impact the reef or the world, but we can assume that they're all playing some important role in there somehow. But a handful of these species, really probably, I would say 10, maybe 10 species, are really the ones that you see when you're out on the reef. They're the ones that form, colonies the size of this tiki that we're sitting in.
Wow.
And that's where the fish like to live, and that's where millions of eggs come for the next generation of corals. And so when we talk about ecosystem services, which for reefs often means habitat, which is important not just for diversity, but for people who like to fish, and people who like to snorkel and see sharks and fish and all these other things. So it's commercially very important as well. Those big reef building species are also really, really important for us here in the Florida Keys for shoreline protection. You lose the reef, we now have 10-foot waves hitting our shores every single day instead of the 2-inch waves that we have. So really our way of life here in South Florida and the Florida Keys in particular would not exist as we know it without the reef. And it's those reef building species that are what really contributes to that. And so I hate to say we value some species over others, but when we're talking about ecosystem services, we have to.
At the risk of putting you at the spot, would you mind kind of naming some of those species?
Sure.
The top 10 you mentioned, yeah.
Yeah, I don't know the common names, and most people don't use them anyway.
Yeah.
But sure, so I had mentioned the Elkhorn Coral, which is no longer a big reef building species, except in areas where it still is. And a lot of restoration efforts are really focusing on that species because of how important it is for ecosystem services. But Orbicella Fabulata is one. I think mountainous star coral is maybe its common name because it forms these big mountains. You know, that's what makes up the bulk of these reefs. Montastria cavernosa forms these similar really big colonies that are super important. Some of the brain corals can really get quite large and have a big impact on that. Culpophilia natans and Pseudodiploria strigosa are two that spring to mind. I would say those are probably the ones that are the biggest, but also have enough commonality that they really contribute. So like the pillar coral forms these huge, beautiful colonies, but we call them the sprinkle species sometimes. You know, they're just kind of around and they're cool when you have them on the reef, but they're not necessarily the ones that are protecting your house during a hurricane.
And then you mentioned how a crab is, right, to kind of just, you mentioned how they're typically on top of the reef or something like that, right?
Palmata is.
Yeah.
Cervicornis can grow sort of throughout a depth range, but you know, when you talk about reef zonation, and these are geological characteristics that have been described decades and decades ago, the top of the reef is called the Palmata zone because it used to be full of Palmata. And now people look at it and they're like, why is this called this thing? There's none of this thing here.
Is Palmata to the coral?
Palmata is a Acropora palmata was the Elkhorn that really dominated that zone. And it's not an easy place for most corals to grow. And so when that all died off, there's nothing really to replace it. It's just kind of a flat, rubbly zone now that maybe has some Polyphoa, which is another type of invert that grows on it, but there's no structure there, there's no habitat there anymore for the things that used to rely on that zone.
So elaborate a little bit more about this zonation you keep on mentioning.
Yeah.
Right? So you have the, let's call them Acropora on the top, right, and then kind of break down the different levels, and then is there a disease that affects one level more than another, like that type of thing?
Oh, that's a great question. Yeah, so the zones are generally depth-based, and we think a lot about the reef crest is sort of where the waves are hitting and breaking. It's a very high energy zone, which is one of the reasons it's hard for a lot of species to live there because they're just getting pounded by waves all the time. But that's sort of that top shallow, and then for the reefs I'm talking about, which are the ones kind of out front, like our barrier reefs, you'll often get what's called a spur and groove zonation. So you get these sort of big humps of coral and old coral, and then sort of these sand channels in between, which is super cool to dive and to snorkel. People love to do that because you kind of get that contrast between the sand and the big tall reefs. And some of those can be, 20-something feet high. We talk about how flat Florida is, but it's not offshore. It just is right here. And so you get this spur and groove zonation, and that kind of works its way down, and you get different species of corals that need that habitat. A lot of these reef building species, your Orbicella Fabulatas, your Montastria cavernosas, your brain corals, those all love that kind of habitat. Something we don't have a lot of in Florida, but it is in some places, and it's very prevalent throughout other parts of the Caribbean, is what we call the mesophotic reef. And so when you get down deeper, sometimes you get those same species of corals, but they grow differently. They need more light because they're getting deeper. And so a lot of them will really spread out. Instead of getting these kind of tall, pokey corals, you start to get these kind of flat areas of sometimes the same species. Sometimes you'll get some slightly different species that start to mix in down there. And there's been a lot of talk about whether mesophotic reefs could be the future of supplying the next generation of corals, because they seem to be less susceptible to bleaching because it doesn't get as hot down there.
Water's cooler.
Right, yeah. And so maybe all of those individuals are still producing all of the eggs that we need that could then maybe repopulate these shallow zones, which is a great theory for bleaching. Doesn't really seem to work for disease. Unfortunately, every disease I can think of doesn't discriminate based on depth. There might be some exceptions to that, I'm not sure of, but every one I can think of has been found from shallow all the way down to deep.
And are all these corals you're mentioning hard corals, or are they
Yes, I'm only speaking about hard corals here. So we do also have octocorals, which are another really important part of our ecosystem and are very common on our reefs now. I mentioned earlier that in some places we see a shift from coral-dominated to algal-dominated ecosystems, particularly with nutrient enrichment and things like that. And again, we really don't see that in Florida. The sort of prevailing theory is that we have these herbivores that keep the algae in check. But now there's still substrate available. When the coral dies, something's going to settle there. And in the case of Florida Keys, that tends to be octocorals, which provide some habitat. It's not nothing, but it's certainly not the same level of ecosystem services that these hard corals provide.
So the reef in the Florida Keys, right, is only living coral reef in the United States. Is that accurate? Or
the continental United States? Yeah. So Hawaii has corals.
Puerto Rico.
The reefs of like the Virgin Islands and Puerto Rico are pretty impressive. We definitely shouldn't discount them. But yeah, the Florida Keys is the only continental reef in the United States.
And to my knowledge, right, it's the third largest reef in the world, right?
Yep. Okay, yep, so, in terms of length, yeah.
So why is that significant? Why should someone care about that?
So there's been a really interesting push in Florida recently to make people more aware of that and really help to identify that as part of our history, our culture, our heritage. Australia, and I think Australia, which is the first largest, is such a great example of, even if an Australian has never been to the Great Barrier Reef, they would be appalled to learn that bad things are happening. And bad things are happening, and people are appalled, and they're putting tons of money towards the Great Barrier Reef. And it's such a national identity for Australia. And here in Florida, there are people that live a couple of 100 yards from Florida's coral reef, particularly in sort of Miami where the reef is quite close, who have absolutely no idea it's there. Wow. And it's crazy that we don't sort of have that connection the way that, for example, Australia does. I appreciate the challenges of someone in Kansas understanding and caring about coral reefs or Florida's coral reef. It seems very far away. But in South Florida, again, we could not live here without the reef. And it's crazy to me that there are people who don't realize that. Your house would be underwater if that wasn't there. How do you not know that?
Well, I think you kind of touched upon almost an irony that exists, right? So it's these hurricanes, right, are destroying these coral reefs as a result of global climate change. But coral reefs are such an important first line of defense against this erosion and this kind of other tragic effects of hurricanes. Yeah. So it's you kind of have this oxymoron that's kind of happening.
Yeah. Well, and so hurricanes aren't inherently detrimental to coral reefs. They have evolved in the world of hurricanes, and there are a lot of corals, particularly those branching corals that sort of propagate from hurricanes, and particularly less severe hurricanes. They can cause breakage of coral colonies, but then they land somewhere and they grow and they form a new colony, or they help spread these genotypes around the reef. And so I don't want to say that they can't survive hurricanes, but they can't survive hurricanes on top of everything else that we're doing to them. But I would say I agree with you in that I think hurricanes really increase awareness of the importance of coral reefs, because that is when people realize that those waves are not that far away from their house at any given point in time. And we've been talking a lot about, when we think about rebuilding after hurricanes and we think about infrastructure to protect, houses and commercial developments from storm surge and hurricanes, we can put that money into a seawall, or we could put that money into the reef, which has been a proven protector. The reason we have the land is because of that, and it's been there for thousands and thousands of years doing that job. So thinking about whether there are ways to increase awareness of using the funding that is allotted to help recover and prevent natural disasters, to do so in a way that's more natural and ultimately more effective.
So you've been involved in academia for a while, right?
Yeah.
You've been studying this for 20 years, and yet there does seem like you're mentioning this rather drastic gap between what the scientists are thinking and doing and saying and what the public is perceiving.
Yeah.
How do we as academics bridge that gap?
I don't know. We're terrible at it. Something I think I've seen even just in my career is a rise in jobs to translate science into to public awareness. I think we all, scientists included, and maybe in particular, have an obligation to tell our story and to make sure that our findings are getting out there, but I don't always think we're the best people to do it. And I think asking people who maybe aren't very good at PR or at public speaking or things like that to take the lead on doing so is maybe not the best use of resources, you know.
Fair enough.
You know, maybe scientists who are terrible at public speaking or at sharing their news can focus their efforts on being good scientists, but forming those partnerships with people who are very good at communicating and getting the word out to the public about these important issues. So I think there's a lot to be done there. I see things going in the right direction. But yeah, I definitely think there's a lot of partnerships that are forming and really need to continue to be formed to help get that word out and to get it out in a way that is understandable.
Conservation and sustainability are rather loaded words, right? Almost overused at this point. But what do those two words specifically, how do you as a scientist, specific in your own individual interpretation, define those two words?
Conservation and sustainability?
Yeah.
Ooh, that's a good question. And are those two related? So I think sustainability is a part of conservation. And to me, both of those words will never succeed if the public isn't involved. You know, I cannot do conservation on my own. I cannot do sustainability on my own. I need everybody to do that. Get a little emotional talking about it. So I think this is where the translation of findings to the public is really important. As scientists, we can say, if you do this, this is likely to happen. If you don't do this, this is likely to happen. But we can't make anybody do that, nor should we. You know, we need to figure out a way to inspire people to understand what those two choices are, and to make the decisions that will lead to one of those choices, knowing what those outcomes are going to be.
And what does the word sustainable development mean to you?
So sustainable development is a really interesting concept in the Keys. We are an area of critical state concern. We also have a safety obligation to get everybody out in a hurricane. And so in the Florida Keys, we have something called ROGO, the Rate of Growth Ordinance, which says that we will not develop faster than a certain rate, and there will be a point where we stop developing, and we are not far from that point. Getting a ROGO permit is a huge deal when you talk about buying a house or setting up a new hotel or something like that. And so we inherently have very sustainable development because we're running out of room, and the law says that we can't do anything else. And I sometimes forget that that's not the case everywhere. You know, I go up to the mainland and think, how are all these houses being built? It's just this massive expansion. And I don't know what the solution to that is. You know, I understand the economic challenges associated with development and tourism in particular in Florida is such a lifeblood of this state. And I don't have the answers to how you do that in a way that doesn't destroy the thing that people are coming here to see.
So when you were kind of defining conservation and sustainability, right? You're obviously incredibly passionate about it. You know, what is it specifically? You know, what makes you tick? Why corals? You know, I mean, because it's a beautiful thing.
Yeah. Thanks. Don't feel very beautiful right now. So I think locally, this place used to be prettier than it is. And, you know, when I hear the stories of these old timers talk about what it looked like, you know, in the 80s even, which was not that long before I started diving here, it just makes me really sad I didn't get to see that. So yeah, I think for me, like, how can I make it so other people don't feel that way? Yeah, so it makes me sad that I didn't get to see that, and anything I can do to help either myself in 20 years or these kids at Seacamp in 20 years, be able to see even a fraction of how beautiful this place is. I just think that's super important.
And I guess, last thing I'm going to ask you is, what do you have to say to the world, right? To anybody that's listening, if you can tell them a couple things, right? What would you say? Kind of roar.
Well, I think from a conservation perspective, it's really hard to care about something that you don't know about. And so, I always joke, like, why are you inside watching TV on Shark Week? Go outside and play with sharks. Like, just go outside and play. Get to know whether it's the forest, like right next door to your house, or if you can come here to the Florida Keys and stay at Seacamp and go out snorkeling, or send your kids, or whatever that looks like. Go outside and see what the world has to offer and see how valuable that is. And that, that's why you want to save it.
Well, unless you have any more questions, Adolfo?
My question, I do have a couple, but
Yeah.
I guess one of them is, like, we're at Seacamp, we have all types of kids coming in all the time.
Yeah.
What is the reaction when they find out about all this going on in here with the coral reefs, or just with the corals overall, or the fish?
Sure.
Yeah, with the marine life. Like, what is their view, their perspectives coming in? I'm sure some of them probably did not know as much after they came over, but what's their experience like?
So I haven't taught at Seacamp in almost 20 years, but I can imagine, if I imagine their experience today is the same as the kids that I had 20 years ago, and I don't know why it wouldn't be. It varies a lot by the kid and a lot of where they're from. I love Locals Keys kids, these are the kids that I know in my neighborhood, and
Right.
they're great. But they are always the most underwhelmed at Seacamp because they're lucky enough to live here. They've already seen a lot of this stuff and they think it's cool, but like, whatever, we saw it yesterday out with mom and dad on the boat. When we get kids from somewhere not near an ocean, those are the ones, this is like a life-changing, mind-blowing experience. They've never thought about a coral reef before, or maybe even put a mask on their face and looked under the water before, and that's really cool and inspiring. Something that Seacamp and really all of the amazing environmental ed foundations that we have in the Keys do is, it's not just about the coral reef, for example. We go to the reef, but we also walk along the mangroves and see what lives there, and go look at sponges in the backcountry waters, and really talking about those ecosystem connections. And I think a lot of that is helping to understand how everything is related to itself. And when I talk about us being downstream of everything, like what happens in Lake Okeechobee, and even just what happens in the backcountry where they're snorkeling right there, is going to impact these mangroves and that coral reef. And so I think really pushing those connections and understanding that this is all one system, and that particularly it's water, all of this is tied together by the water, I think is something that these organizations really try to make a point of, and I think these kids really walk away with the idea that this isn't just a thing that happens out there. This is something that that impacts me, but also that I impact. When I do a thing to the water up there, it is going to impact this area down here. So, I think besides being blown away, there's that message of connection. That comes away.
Definitely.
Yeah.
One last question I did have, and I think it goes back almost to the beginning, but you were talking about climate change.
Yeah.
And I'm just thinking statistically, if we keep going the way that we're going, how further can we even push ourselves to, reach that peak?
Yeah.
I guess that peak where we really have no control anymore over the coral reefs. And
Yeah.
if so, like how long are we talking in here about years, decades? Let's say even decades at this point. If we keep continuing, I guess, the trend that's been going on for the past 20 years.
Right.
even through restoration, we might be helping. You mentioned, like there's only like so much that we're able to do because we're still figuring out what's the best method to do it at a global scale or larger scale.
Yeah.
So how much can we push, I guess, be the way that we're doing, not really doing as much as we can when it comes to climate change?
Yeah.
What does that look like?
We can't push that. We're already in
at
a
that.
lot of trouble.
We're already
It's
so
just
every
a question of how much trouble we want to get into.
So at this point, we're just playing the not playing the game, but it's like we need to just do something about climate change.
We are losing things. We are going to continue to lose things. How much are we willing to lose? And I think this is where that conservation message of, not me. I'm not a climate change modeler, but these IPCC reports come out. And they say, if we do this, this is what's going to happen. If we do this, this is what's going to happen. And there's projections of ocean acidification and of sea level rise. And somehow I don't think the public has made that connection of, this means me. Like, if we do this, my house will be underwater. If we don't do this, maybe my house won't. Whatever those situations are, we're not translating that to that personal connection somehow yet.
Do you feel like the Key West community, they're like, they're more aware about what's going on, but do they participate or help organize any groups, cleaning groups, or I don't know, how do they?
Yeah, this is a really environmentally minded community. Yeah. We have to be. We're so closely tied to it, not just the ocean, but people live here because it's beautiful, And there are different opinions everywhere you go, but I think in general, when you live on a low elevation island, there are different opinions everywhere you go, but by and large, the people in the Florida Keys acknowledge climate change. We see it, we know the impacts of it, it is very real. And I would say more than a lot of other places, we realize that there is a responsibility to our environment here. It's hard on things like climate change. We're a relatively small population and aren't going to make a huge dent in climate change in and of ourselves. But we can do beach cleanups, we can do coral restoration, we can plant mangroves, we can, make sure that we have rules about tree trimming or, caring for our endangered species that we have. And I think that those local rules for protecting our environment as we can are, very largely supported in this community.
All right, so to conclude, I'm going to ask this last question. This is your opinion and, it's your experiences in the Keys. What is your favorite spot in the area, like in the Keys? Like which area would you say, man, I love going there, I wish I could be there, like?
Now or 10 years ago? Because it's changed for sure.
Well, maybe, but yeah, that'd be great.
So we have lost some really fantastic dive spots because of stony coral tissue loss disease. We used to have a site called Pillar Coral Forest. I had talked about these pillar corals, and it was 150 of these colonies. It was just swimming through the most beautiful forest of corals, and the fish, and you'd always see turtles and sharks and everything. It was just a really magical place. And unfortunately now that's just a graveyard of rubble. And so losing those places is really hard. The dry Tortugas is probably one of my favorite places for a lot of reasons. Topside, it's got this cool old fort and it's beautiful and there's a really neat history. But there's also, huge colonies of nesting seabirds, tens of thousands of seabirds that come there, and that makes it a really magical place. Lots of sea turtles. And then underwater, it's just got a huge amount of coral reef. They've been getting hit really hard with stony coral tissue loss disease recently. Unfortunately, I think a lot of those classic beautiful places are not going to be so beautiful anymore. But it's still a kind of this pristine part of the Florida Keys in terms of remoteness and as far as water quality goes, that's about as good as it gets out there. And so it's clear and pretty and history, and it's a national park, which I'm a huge fan of our national park system, and so that's a pretty magical place. Plus, you're totally off the grid, and that's
you're off
pretty
the
cool
grid.
too.
There you go. I like that. Human interaction. In there.
Yeah.
All right. Well, I think that's
it. Yeah.
that's it for now. Thank you.
Thank
so
you,
much,
guys.
Karen.
Really appreciate your time today.
Absolutely. Yeah. Good luck with your work and your project. This is really exciting.
Thank you.
Yeah.